Hello and welcome everyone. So in this video I'm going to do a walkthrough of the solution to the first exam in Economics of Entrepreneurship. So first with the 9 multiple choice questions, though potentially in a different order than you've seen, then the 4 longer form, true false with a brief explanation question, and then the longer form questions. I'll do that across these different documents that I've got right there. So, all right, firstly, starting here, where there's economies of scope between products, selling off an unprofitable subsidiary could lead to, well, potentially only a minor reduction in cost. Remember, with economies of scope, it's already cheaper to produce those products jointly by one firm under the same organizational structure, access to capital, entrepreneurial, managerial talent, than it would have been to have separate entities producing those things in the first place. And so if we are already taking advantage of economies of scope to reduce costs overall, then maybe the costs only fall by a little bit when you stop producing one of those things over which there had been economies of scope. All right, so consider a monopoly where the inverse demand for the product is given by price is equal to 50 minus 2q. Total costs are estimated to be 100 plus 2q plus q squared. At the profit maximizing combination of output and price, monopoly profit is. All right, so we need marginal revenue equal to marginal cost. Remember, the marginal revenue is going to have the same vertical intercept as the inverse demand, but then twice the slope. So I've written 50 minus 4q is equal to, this is the marginal cost, just take the derivative with respect to q, so it's going to be 2 plus 2q, okay? Then solving 50 minus 2 is 48. Move the 4q to the other side, that's 6q. 48 divided by 6 is 8. Then we need to get profits, or we need to get price. So 50 minus 16 is 34 is the price. Price, or 34 times 8 is going to be revenue, and then minus the total cost brings us to a profit of 92. The creation of a new product is referred to as product innovation. Remember, we talked about process innovation as being where you'd have a cost-saving innovation, and then we're contrasting that with a product innovation, which is introducing a new product. In a monopoly where the marginal revenue and price are given by $10 and $20, the price elasticity of demand is, okay, so we want to start with our assumption that they're going to produce where marginal revenue equals marginal cost. Then we have our percentage markup formula, so price minus marginal cost divided by price equals 1 over price elasticity of demand. All right, so the price was 20. The marginal cost is therefore 10. 20 minus 10 is 10 divided by 20, which is the price, is, well, that's our 1/2. And then this is equal to 1 over minus E minus the price elasticity of demand, because this is going to be, E is already negative, epsilon's already negative because of our downward sloping demand curve. Alternatively, we could have, we could have the price elasticity of demand represented in absolute value, but then we wouldn't have this minus. So anyway, here we do. So we're going to have 10. We're going to have 10 over 20 is 1/2. And then, let's see, this is in the denominator. Moving, cross-multiplying both sides, we'll have what? Minus epsilon is equal to 2, or epsilon is equal to minus 2. To engage in first-degree price discrimination, a firm must be able to, well, it's got to have markup. The ability to produce where price is greater than marginal cost is market power. Actually, for first-degree price discrimination, must also know consumers' maximal willingness to pay, because this is personalized pricing. This is where you're going to set the price equal to their willingness to pay. And you need to be able to prevent low-value customers from reselling to high-value customers. That's the arbitrage opportunity that you want to disallow. Persuasive advertising influences demand by altering the underlying taste of customers, right? Persuading them that they're going to be served by your product. All right, so if firm A has strictly higher marginal cost than firm B, they compete as identical product Bertrand firms, which will not occur. Well, Bertrand firms are competing in price. The higher cost firm is going to have a higher price. And so if we have a lower marginal cost firm is firm B is always going to be able, in equilibrium, is going to be able to produce below, is going to be able to price below firm A. We're not going to have a situation where firm A is going to price below firm B because they've got the higher costs. All right. Two firms compete as a stackelberg duopoly. They face demand. Price is equal to 100 minus 3q. The cost function for each firm is just total cost is equal to 4q. What are the outputs for the two firms? Okay, so there is a formula to find the leader and followers quantities directly. It's not exactly what we developed in class. Turns out it's like, so the one we had where if the coefficient here was equal to 1, then it was just the leader as A minus C, where A is the vertical intercept of the inverse demand, and then C is the marginal cost. So it'd be A minus C divided by 2 is the leader's output. The follower's output is A minus C divided by 4. However, because we've got this 3 here, actually, we can't use the formula I just mentioned. There's one just like it. Actually, the 3 comes down here. It's actually A minus C divided by 2D, where D is this coefficient. So that's what I did here. So the outputs are going to be 16 and 8 respectively. Or suppose like you're doing that, you're like, okay, so none of these are working. What do? Well, you solve the problem the long way, which is kind of just the right way to do stackelberg. So to do this, we want to find the follower's reaction curve, plug it into the leader's profit, and then find the first order condition. It's actually not that bad. It looks kind of terrible the way that I've written this out here because it's not fitting on the screen so well. I don't know where I can put this, making myself car sick, whatever. So here is the follower's profit function. So this is like the price, inverse demand, times the quantity minus the cost. And then just collecting like terms and taking the derivative, we find the follower's reaction curve is going to be 16 minus 1/2 L. Remember the way we solve stackelberg? It's different than Cournot. When we've got the follower's reaction curve, we're going to drop this into the leader's profit function. So whereas like with the follower, we just had our inverse demand had like L for leader and F for follower. When we get to our leader's profit function, what we're going to do is we'll replace this F, which is just a constant, with a function, because we realize that the leader's making their choice with the understanding that the follower is observing this and then therefore reacting. So we need to have the follower's reaction curve in the leader's profit function. That's what this is doing. So it's going to be 100 minus 3L minus 3F of L, actually. So this right here is the follower. I can't highlight it. This is the follower's reaction curve as a function of the leader's choice. That's what this is doing. You see this right there. And so this always looks horrible, but after you clean it up, it cleans up really nicely. And before you even take the derivative, it starts looking a lot better. And then I've done that. I think I did the algebra and then I took the derivative kind of all in one larger step. But then solving again, you find, the leader's output is going to be 16. If the leader's output is 16, the follower's output is going to be 1/2 times 16, which is 8. 16 minus 8 is 8. So that's this one right there. All right. And I expect most people probably did it this way because, well, maybe by guess and test you could have recognized, I lost that thing. Anyway, so no, I didn't. Here it is. I don't know. No, don't mind me. Don't mind me. How about this? Let's do puppy study break. So here's my puppy, right? Here's Onyx. What's the puppy doing? Puppy sees a bird. What's going to happen next? Puppy's trying to chase the bird. Anyway. All right. So Sue and Janine own identical gas stations. They have identical marginal costs but earn zero economic profits. They constitute a Bertrand oligopoly, right? They have 2 gas stations, probably identical product. They're earning zero economic profits. That's the prediction for the Bertrand oligopoly. Set price equal to marginal cost. Oh, they've got identical marginal cost, so that fits. All right, so here's the short answer, or like true false with one sentence explanation questions. Let me read through them, then I'll just click over to where I've got the write-up. So the first one was a limit price is not a price control. However, a firm might set a limit price to restrict output available in the market in order to prevent prices from falling any further. Whenever a firm can sell its main product as well as offer a useful complementary product or service, it'll generate higher profits using bundling than pricing each separately. There's differences across industries, but generally speaking, a firm is able to effectively deter entry through a price war made possible by building out additional productive capacity after the firm has entered. And then a firm innovates to reduce its per unit cost below that of its rivals, will be able to maximize profits by producing output where marginal revenue equals marginal cost and charging the associated monopoly price. All right, so these are all false. The first one, what's the problem? A firm that's able to innovate reduces its... Oh, this is out of order. I should have put this in the same order as what we just had. Sorry. But this is what we'll do from here now. So a firm that's able to innovate reduces its per unit cost below that of its rivals, able to maximize profits producing where the output is, where marginal revenue equals marginal cost and associated monopoly price. No, the problem is, like, if you had a small innovation, you wouldn't be able to produce where marginal revenue equals marginal cost. So for these, I'm looking for you to say basically, well, firstly, some of the points are for true or false correctly. They should all be false. And then for the explanation, like here, what I'm really looking for people to do is say something like small innovation. So contrast between small innovation and large innovation. If you have a large innovation, you can produce where marginal revenue equals marginal cost, and then you're just a standard monopoly. If not, you can still operate as a monopoly, but you're not going to be able to produce where marginal revenue equals marginal cost. Instead, you're going to just barely be able to undercut the rivals. All right, so limit price is not a price control. Well, limit price is an entry deterrent strategy. The firm's going to set the price artificially low, possibly overproducing relative to the monopoly. So we're not actually going to see output restricted. We're going to see maybe more quantity produced than in absence of limit pricing. Now, true in the long run, successful entry deterrence preserves monopoly pricing, but a true answer, if you said true, must clarify the long run impact of shielding against entry. So if you're saying it was true, then I wanted to see something about picking up on the fact that prices wouldn't fall any lower in the future. You'd have to say something about, well, when you're no longer worried about the threat of entry, then you're able to raise prices up. So a couple different, some of these there's a little bit of room for interpretation, but then I was looking to see was your logic consistent with that interpretation, and that was what was necessary for full credit if you answer something a little bit different than what I had in mind here. All right, so there's differences across industries. Generally speaking, a firm is able to deter entry through price war. No. What's the problem? Building out additional capacity after the rival has entered. That's not a credible threat. So the additional capacity must be built out prior to entry. After entry, the price war is generally not a credible threat. Whenever a firm can sell its main product as well as offer a useful complementary product or service, it'll generate higher profits using bundling. No, not whenever, because the success of bundling depends on if you have negatively correlated preferences. Otherwise, separate pricing might be superior. The merger of complements intuition from class actually isn't really relevant because we have a single firm that's already producing both and hence already having internalized the externality of price of one product on the price of the other product. So there wouldn't be additional gains from that. Okay, so then for the longer form questions. So the first one, suppose you're operating in a market with two distinct segments. There's 200 consumers represented with inverse demand 120 minus 2Q, 100 consumers represented with inverse demand of 120 minus Q. Your costs are 30Q regardless of who you're selling to. Two-part tariff pricing strategy. The first one is you're trying to determine if you've got to sell the same per unit price for now set equal to marginal cost and the same fixed price for both groups. You want to find, it's basically for part A, you're trying to determine, I have to set price equal to marginal cost. Is it better to get the tariff portion, the fixed component from this group or from this group? And so you have to find the consumer surplus under both of those demand curves at the price of 30 and then scale according to the number of consumers. It turns out it's actually not going to matter. It's going to be the same profits either way. Then for part C, suppose you're able to separate the two groups, offer each its own per unit price and fixed profits, find those optimal two-part tariff prices. That's actually, why did I skip there? It's because once you've done that work, then that is part C. Then you're no longer deciding, should I use this group's fixed fee for both, or should I use this one's fixed fee for both? No, instead you're saying, all right, let's set price equal to marginal cost. These consumers are getting their own fixed access fee, and these consumers are getting their own fixed access fee, each respectively equal to their consumer surplus at the price of 30, and that's going to maximize profits. So that's why I skipped there. Okay, so part B is the one that's a little bit more in-depth. This is just like part B in the problem set. This is just like the longer example from lecture. All right, so but I'll just do this, and then I'll go to the next one. It's easier if I just read the question and then show the work than kind of ask us to remember. So, all right, what I did is I drew out the graph for each of the inverse demands. Now, I need actually the demand curve in kind of both formats. I need like inverse demand, and then I need like the regular demand. I need inverse demand to get the triangle, or at least to make it easier to visualize and be able to get consumer surplus. And then I need the ordinary demand curve to plug into my profit function down here. But for part A, basically what I'm doing is I'm trying to find the area of under the area of consumer surplus at the price of 30, right? That's just the area of this triangle and then the area of this triangle respectively. So it's 1/2 base times height, or it's going to be 1/2 times 90 times 45, right? This is 120 minus 30, that's this length right here. And then 60 minus 1/2 30, that's from the quantity associated with the given price, such as 30 is right here. So that's giving me this quantity is what this is doing. That's 45 actually. So if I calculate this is 2,025 per person, and I've got 200 such consumers. Over here, it turns out this area is just going to be 120 minus 30, that's 90 squared times 1/2, or an area of 40/50, right? And I've got 100 of those consumers. Well, it turns out 100 times this is equal to 200 times that. So it's equal either way. So it turns out it doesn't matter which one that we set. Profits are going to be the same either way. And then that's actually the insight for that gives us our profits for the optimal two-part tariff in Part C, where we're able to isolate the two groups and give them their own price and access fee. So then basically I'm going to get my 225 from these 200 consumers plus my 450 from these consumers right here. All right. Let's see. And then the more involved one. So what I want to do is I want to get whichever is the smaller group, right? I want to base my tariff that I'm going to share jointly off of that consumer surplus. So the smaller demand group was this one. So what I'm going to do is I'm going to set some price P, and I'm going to determine what's the area of this triangle associated with that price P. And then I'm going to solve optimally by differentiated to maximize profits to find what that P is in the first place. All right, so the area of this thing is going to be 120 minus P. Then this is going to be 60 minus 1/2 P gets me whatever is this quantity, noting that the higher is this price, the lower is the quantity, and then vice versa. Anyway, that's this expression right here. It's going to be 1/2 times 120 minus P times 60 minus 1/2 P. I'm going to get 300 such consumers buying access at that tariff. Then I've got my per unit profits, my 200 consumers. This is markup. This is price minus marginal cost, and then this is demand. This is just the quantity at whatever is that price P for this group. And then for this other group, there's 100 such consumers. Again, here's the per unit price. Here's the markup, and then here's 120 minus P. That was the quantity. All right, so then what I did just to kind of simplify the math a little bit is I said, oh, wait a second, I can factor out some stuff here. I can factor out a 2. So if I pull a 2 out of here and here, I'm going to get 60 minus 1/2. Oh, but that allows me to write this as 60 minus 1/2 P squared. And then it's easier for me to take the derivative because I got fewer terms to worry about. So that's why I did that. When you pull out that 2, it cancels with this 1/2, and so it's just 300 times this stuff. Taking the derivative, it's 2 times 300 is 600 times the inside, and then times the derivative of the inside. That's this minus 1/2. Right, and then over here, I'm going to take 200 times 6 minus 1/2 P times the derivative here was 1. Oh, I did that over there. Never mind. For this first one, I did 200 times the derivative of the second. That was minus 1/2, and then times the first. Right, this is just product rule. Maybe I wrote this in other order, but it's just the product rule to do these derivatives. I did the same thing over here. 100 times 100 times P minus 30, that's this right here, times the derivative of the inside, that was minus 1. And then over here, this is going to be 100 times 120 minus P times the derivative here, which is just 1. So that's where I got this. It's equal to 0 because that's our first order condition. And then from there, it's just cleaning up. The first thing that I do is I'm going to multiply the negative by whatever is inside the parentheses here to flip that sign. So you notice I did that throughout. So here I had a minus 1/2. Instead, I'm going to write this as 300 times 1/2 P minus 60, right? So I switched the order. That's what you can do when you flip the sign. Here I've got a minus 1/2. I'm going to write this as 130 minus P. And then so on and so forth for the whole rest of the line. Then it's just distributing, collecting like terms, and you'll end up with 12,000 is equal to 250 P, or a price of 48. Then I can get my tariff profits. I'm just going to evaluate this expression, my consumer surplus, right, at the price of 40, gives me a tariff profits of $12.96 per person, of which I'll have 300 such consumers. And then my per unit profits for each group, just evaluate this at 48. So this is going to be 200 times 18 times, what was that? It's like 24 or 36 or something like that. And then I got my per unit profits, turns out to be the same for both groups. Summing up, my total profits was 648,000. All right, so the last sort of check is that you're going to see the lowest profits in Part A, then the next highest profits in Part B, and then the optimal tariff was like Part C, where you could separate the two groups. More typically, like in the real world, you're probably doing something closer to, well, I don't know. I shouldn't say that. Part B is like what you would do if you had a suspicion about like what your consumer demand would look like, but don't have super good data. Part C is definitely what you do if you were able to use some type of thing like third-degree price discrimination and sort into these two groups. And then, I don't know, maybe Part A is if you had maybe a little bit lower information, but wanted to use two-part tariff. Okay, so the next one, let me go back to what this was. Suppose a video conferencing platform, think of like Zoom or something, has three types of consumers, A, B, C, with willingness to pay in the table for free, medium, and high-end software. Are they profit maximizing? When they set the price of free equal to free, the medium version equal to 29, and then the price of this price for the high end at 49. So are they profit maximizing? Well, this is a second degree price discrimination one, right? Because each consumer uses at most one version of software. It's not bundling, because with bundling, you'd use potentially all three. But with because I've said they use at most one version of the software, it's not bundling. It's a second degree price discrimination question. So the first thing I want to do is look to see like what is happening at this particular price. So remember, the kind of two dangers with second degree price discrimination is you want to make sure that your low willingness to pay consumers will buy at a price equal to their willingness to pay so that they don't leave the market. And then you don't want your higher willingness to pay consumers pretending that they're lower willingness to pay consumers and running off with whatever those profits, right? So you don't, like if you have business grade software and then like consumer grade software that's cheaper, you don't want your business customers, your commercial customers just getting by with the free or like lower end consumer grade software. You want them paying for like the corporate license. But anyway, so let's just verify this. Our consumers aren't going to buy, but they're getting it for free. So 0 and 0, fine. I wrote don't buy. They get it for, it doesn't matter. They're getting the item for free. They're not gonna pay anything, I guess is what I should have said there. So we don't need to worry about them. I've already said more than I need to about them. All right. What about my B-type consumers? Well, they could just get the free version, and if they did, their consumer surplus would be they would have paid 6 for it. They'd get it for 0. They get a consumer surplus of 6 if they use the low end, the free software, right? What did they get for the medium software? Their willingness to pay was 35. We're charging them 29. That gives consumer surplus of 6. Okay, so they're indifferent. We'll actually say we'll break the tie in favor of the economic activity, so they'll buy. That's good. What about at the higher? What if they bought the higher end? Oh, their willingness to pay was 37, but we're charging 49, so they're just not going to buy. Yeah, so our type B consumer, yep, they're definitely going to buy the medium grade software. What about our type C consumers? They'd get consumer surplus of 10 if they were to use the free version. They would have paid 10 for it. We're giving away for free. So their consumer surplus for the free version is 10. What about for the medium one? Well, they would have paid 39. We're charging 29. So now their consumer surplus is 10 for the medium one. So they're indifferent actually between the free and the medium grade software. But what about the high end? They would have been paying 60 for it. We're going to charge them 49. And that actually gives consumer surplus so 60, 40, yeah. So they're getting consumer surplus of 11. Yeah, they're going to buy the higher end version. So then our profits are going to be 0 plus 29 plus 49, which is 78, which is good. Can we do better? Actually, we can. And so one thing we could do is we could say, all right, well, what if we don't worry so much about our lower end group? We're just giving it away for free anyway. Why don't we just set the price equal to 6? And either way, we're getting nothing from our lower group, right? And so what if we set the price of the lower end equal to 6? A is not going to buy either way, so don't worry about them. What about our B-type consumers? Well, if they buy the low end, if they buy what should have been the free version for 6, they're going to get 0 consumer surplus. If we charge them 35 for the medium grade software, essentially treating our B consumers as our lower grade lower willingness to pay consumers, their consumer surplus is going to be 0. 35 minus 35. Okay, fine, but they're indifferent between that and the free version, so we'll break the tie in favor of the economic activity. Good. Would they buy the high end if we charged 56 for it? Well, let's see. Their willingness to pay was 37, so no. What about our higher end consumers or type C consumers? What are they going to be interested in doing? Well, if they paid 6 for the lowest version, they'd come away with consumer surplus of 4. Also, if we charge them 35 for the medium grade, they'll come away with consumer surplus of 4 as well, right? So consumer surplus is going to be 4 either way, and at the price of 56. Consumer surplus is going to be 60 minus 56. That's consumer surplus of 4. So this actually works. This would get them each to buy the intended product. And then our profits would be 35 plus 56, which is 91. This actually beats the original that I had listed in the problem. So this would be the profit maximizing version. So that's what we're looking for. Okay. And then the next one was, suppose 2 of your friends are interested in launching separate businesses. They want to collaborate in the sense of serving the same consumers, but don't want to compete directly. They're selling complements. So suppose the following demand curve describes the market. 12 minus P1 is equal, or 12 minus P1 minus P2, where P1 is set by firm 1 and P2 by firm 2. They're able to produce costlessly. Are they better off basically operating separately or merging? So are you correct or mistaken? You've said that they can increase their profits by selling more units at a lower price if they merge their business rather than selling separately. All right, so to really find out, we've got to just calculate quickly. So suppose they're pricing separately, what happens? Well, here would be firm 1's profits. So this is price times quantity, and then minus cost is just 0 because we had said that we could serve the market costlessly. Take a derivative with respect to the choice variable. That was P1 right here. And so P1 is going to be equal to 12 minus P2 over 2. That's firm 1's reaction to firm 2's choice. Or 6 minus 1/2 P2. The game's symmetric, so by symmetry, we have firm 2's reaction to firm 1's price is just 6 minus 1/2 P1. Or you could redo the profit from firm 2's perspective. That's just as good. Either way, we've got a system of reaction curves to solve, and when we do that, we find the equilibrium price is going to be a price of 4, set by both. The quantity is going to be 4, 12 minus 8 is 4, and then profits are going to be 16 for both, or jointly 32. What if they were to merge and produce and set the price of the bundle jointly? So if we set the price jointly for the two products for the system, right? Then the merged firm is going to have demand of 12 minus P, or we'll have profit is equal to price times 12 minus P. Then differentiating with respect to the choice of the system price, it'll be 12 minus 2p is equal to 0, or price is equal to 6. The quantity would then be quantity be 6 for the system, right? And then profits are going to be 6 times 6, or 36, versus the joint profits of 32. Yeah, it's better to merge. The last one was a 5 forces analysis. So we want to look at the 5 forces analysis for an ice cream parlor on South University. So I was looking for something kind of like this. There's a lot of, so it kind of depended on your explanation. Here's kind of how I thought about it, though. We'd expect to have relatively low rivalry. I mean, there's Michigan Creamery, but thinking about campus traffic, that's kind of far away. It's not like on the other side of the diag. That's far enough away. Although, worth mentioning. Let's see. Threat from entry, pretty low. Kind of depends on the current leases. It would depend, like, if there's not a whole lot of space right there, so for that particular corner, right? Buyers, well, individual students are buyers, each buying kind of a low quantity, and so low buyer power. Seller market power. Well, it's perishable, and so that's relevant because this kind of constrains the places we could potentially source product like inputs from, especially if you're going to make the ice cream on site or something like this. Either way, kind of constrains where you'd be sourcing inputs for ice cream from because it's food, right? Substitutes, yeah, there's lots of treats nearby. There's lots of different things. And so for substitutes, we're thinking like outside of the industry. But basically, I was looking for something along these lines, and most people's was pretty reasonable. Okay, so that brings us to the end here. Hope you enjoyed the video. See you next time.